So we're just going to do some average atomic mass calculations, and instead of reinventing examples, let's do the first couple of this worksheet together, and then you'll do a few of them on your own, okay? But last week we talked about lithium-6 and lithium-7. Do you remember? Okay. Some of you built lithium-6 in your FET, and others built lithium-7. And you told me that both atoms were stable, right? Okay. So both of those exist. Both of those are isotopes of lithium. Those are the two most common isotopes of lithium. Now, if you were in math class and they asked you to find the average of lithium-6 and lithium-7, what would the average of those mass numbers be for you, according to math? How do you find an average? Add them up and divide by 2. So 6 plus 7 equals 13. Divided by 2 is 6.5, right? Okay. So to you, that's the average. Look on the periodic table and tell me, what is the average atomic mass of lithium? 6.941. Lithium's number 3. It's over on the left-hand side under hydrogen if you didn't find it. It's 6.94 what? And that's called an average. And it is. That's correct. How do you think they got that average? What do you think the difference between 6.5 and 6.941 is in the calculation of it? Like when you add up and divide by 2, what are you assuming? That they both represent 50% of the average, right? So when you add up and divide by a certain, however many there are, you're assuming that however many there are represented equally compared to each other. Okay, so it's half this, half that. Or if you divide by 3, it's a third this, it's a third that, right? If you divide by 10, it's 1/10 this, 1/10 that, right? That's not how atoms are in nature, okay? These elements exist. There are different types of atoms, but they don't always represent 50% of the total. Okay, so based on the average you see for lithium, 6.941, have a conversation with a partner. Which one do you think is greater than 50%? And which one do you think is less than 50%? And why? Have a conversation. So which one do we think is present in more than 50, like more than 50%? Lithium-7, right? Which means lithium-6 is less than 50%. Okay. What made you decide that? How could you tell? Go ahead, take it away. Oh, you're looking at the example. What's another way you could tell? Right, but how did they get an average atomic mass?
Because the average atomic mass is greater than 6.5, so there's no more.
Right. If you look on the periodic table, the average atomic mass is 6.941, which is closer to which mass number? 7. A lot closer to 7, right? So that indicates to you lithium-7 has to be, and you use the right word, abundant. It's more abundant than lithium-6. What does the word abundant mean? When you have something in abundance, what are you saying? You have a lot of it. You have more than you need, maybe, right? Like we have an abundant amount of periodic tables in this room. Okay. So abundance means a lot. So right, what happens is lithium-6 is, and these numbers are a little bit off, but we're going to go with them anyway. Lithium 6 is 4% abundant. Lithium 7 is 96% abundant, which means if you each went out into nature and found 100 lithium atoms, you should be getting about 4 of them on average are lithium 6, and the other 96 of them on average are lithium 7. That is just what exists in nature. Lithium 7 is a more common isotope than lithium 6, which is why it contributes more to the average atomic mass. Okay, that is called a weighted average. So I'm going to give you a little bit of notes here. Okay, so go ahead. You can copy this down. You'll notice I put this directly below our notes from last week. Okay. So I just added it, and I actually changed my title for this file to Unit 1, Concept 3. You might want to do the same. So here's our information about lithium. Okay. And this is called a weighted average, which means the abundance of each isotope is factored into the average calculation. Okay, so instead of adding up and dividing by 2, we're actually considering what percentage of each isotope is found in nature compared to one another. You use weighted averages both in the classroom because you have 2 types of grades, progress checks and common assessments. What percentage do progress checks weigh? 40, common assessments weigh 60. So those have a much bigger impact on your grade, right? Especially you usually have fewer common assessments. Yeah. Okay, also, for GPA, okay, how does a weighted average figure into your GPA? What makes it weighted? Great. APs and honors, you're getting extra points for, so to speak. Okay, so like this class, compared to CP chemistry, you get a 5% bump just for sitting in here. Okay, so what that means is, for example, in your like in your GPA, okay, if let's say you get a 92 in this class, well, GPA wise, that becomes a 96.6 getting calculated into your GPA. So like a 92 in CP chemistry for the GPA is actually a 96.6 in honors chemistry. Okay, if you take AP classes or AC or those dual enrollment classes, you get a 10% bump. So like a 92 would boost you up to close to 100 in terms of your GPA. So it's a lot. Okay. All right. So let's talk about how to actually calculate this. Go back to this worksheet now. Okay. And we're going to do the first couple together. So the way you do this is you have to account for your percentages. Okay. In fact, I'm going to color code. So lithium 6 has a 4% abundance, and lithium 7 has a 96% abundance. Okay. So how do you deal with a percent when you're putting it in a problem? What do you have to do to the percent? Do you use it as is, or do you have to change it a little bit? You have to change it to a decimal. So 4% is what? 0.04, because you move 2 to the left, times 6, because that's the mass number. So this is your percent. This is your mass number, right? Plus, what's 96% as a decimal? 0.96. We're going to multiply that one by 7. Okay. So go ahead, do that. Take out a calculator. You should have Desmos, okay, on your iPads. You are gonna, just heads up though, you are going to use on your quiz and your test on Wednesday and Friday, it's going to be on paper. So you're going to use like regular calculators. All right. So make sure if you have a calculator, bring it. Otherwise, I'll pass extras out. I have about 30 of them. So we're good. But if you have them with you, if you have them, bring them with you. All right. What'd you get as your answer for this? 6.96, which these percentages are rounded a decent amount, so we are a little bit off. The unit, by the way, is AMU. AMU stands for atomic mass unit because we're talking about very small particles that contribute to the mass of an atom. So they just call it AMU. All right. So because these percentages are rounded a bit, we're a little bit off from what the periodic table says, okay? But are we way far off? No, we're like 200ths off, okay? So we know we did the calculation right. Like, what if you were to get 7.34 as your answer? What should you assume? That you messed up somewhere. Like the nice thing is, you remember I told you like this is the greatest cheat sheet you're ever going to get? The answer to this calculation is pretty much on here. So you can double check what you got. However, you're going to have to show me your work to get full credit. When it says calculate, that means you're going to have to show your calculations and how you got that answer. But you can double check your answer to see, was I close? How did I do? And as long as you're close, then you're fine. You know, it might not be perfectly matching that, but you should be pretty close. Okay. Try number 2 on your own, show work. Okay. Read through number 2, give it a try. I'll give you a couple minutes to attempt that one. So in this example, you have europium 151 with an abundance of 48.03%. How many of you rounded to 48? Good. Don't do that. Okay. Because they are giving you very precise data. Why would you limit the precision of the data you're being supplied? Okay. So like you don't get to drop values. If you're given information, you use the data you're given, okay? So 48.03% would be 0.4803, right? Plus 0.5197 times 153, okay? Now, I'm going to slow this down a little bit for myself and for you because I want to talk to you about what I saw walking around. Okay. So here's my answer to that. See that? That, like, if you do that times 151, that's what you get, right? Or did I mistype it? That's right. Okay. And then my answer to the second part is this. And if I add those two numbers together, oh, for the love. Okay. And here were the answers that I had to these two parts. And when I add my answers together, I got 152.0394 AMU. Raise your hand if that is exactly what you wrote down on paper. A lot of you wrote 152.04. So, look, you don't get to round, okay? You have to use whatever data you're given. There are, because these values, you guys, they do represent precision, okay? And there are rules for how to round in science. And you're going to learn those rules in February, okay? Like, so how many have you ever asked a teacher, like, what do you want us to round to? Hundredths, tenths? How many of you have ever asked that? Okay. You're going to learn when we get to the data portion of this class actually how to round where you can answer that question for yourself because there are rules. But until you know those rules, you don't get to round in here unless I tell you to. You use all the digits you have because these each have 4 decimal places. I would say your answer should have 4 decimal places. Okay. Also, allow me to reiterate, I expect you to show work. This is like a 10-point problem, or this would probably realistically be a 6-point problem. Want to see? Ready? 1, 2, 3, 4, 5, 6. Okay. That would be a 6-point problem. That way, if you make a mistake or if you mistype something in your calculator, I can see that you knew what you were doing. I'm more concerned in your process than your final answer. If your process is right, your final answer will be right. Okay, but you need to learn how to deal with the data. You're not doing math in here. You're using math as a way to interpret data. So you've got to focus on that. Like, how are you using data to show the answer? Okay.